Hello everyone. In this video I am going to show you how to implement Dijkstra algorithm in C++. Dijkstra algorithm computes shortest patches from a given vertex in a graph. Let's take a look at its pseudocode and example illustration of an algorithm. Here we assign 0 as shortest patch to leftmost vertex and infinity to the rest. In first step we update shortest patch to neighbors of source vertex, here t and y. Then we remove source vertex from set Q. In next step we choose from set Q vertex with the lowest value of shortest patch. It is the vertex y with value 5. Next we repeat the same procedure for vertex y. At the end we have computed shortest patches to all vertices. At this time set Q is empty. In pseudocode we initialize source in first line, then we create empty set S and set Q, which contains all the vertices. Next we execute lines 5 to 8 until set Q is not empty. First we extract vertex from Q with the lowest shortest patch, then we relax all of its adjacent vertexes. Relaxing means updating shortest patch of a vertex U if the sum of shortest patch to V plus edge from U to V is lower than previous value of shortest patch. Now let's take a look at implementation of Dijkstra algorithm. As an ID I use Visual Studio. Project is a C++ console application. First we create graph representation. It's a matrix of type double. All the weights in the matrix are non-negative. If there is edge between some vertex and another, corresponding matrix element is greater than 0. Vertices are numbered from 0. First row of a matrix consists of edges adjacent to vertex number 0. For example, first row and second element is weight of patch between vertex 0 and vertex 1. Another thing is that our array is a template type. After clicking definition of a row array, we see that it's defined as a template array which is two-dimensional with element of type t and n times n elements number. Next we have our Dijkstra function, which takes its first parameter graph and second parameter is source vertex, which is 0. Let's see function definition. This function is a template function of type t and is limited to floating points or integers. First line in body of a function is declaration of array G, which holds current shortest patches to all vertices of a graph. We assign infinity, which is maximum value of double type. Next we initialize shortest patch of a source vertex to 0. Then we have another two vectors. Vector S includes processed vertices of a graph and vector Q, which include unprocessed vertices. So Q at the beginning of an algorithm consists of all vertices. Next we have a while loop which iterates until vector Q is non-empty. First we extract vertex from Q that have lowest shortest patch. Then we push back that vertex to vector S. In the next step we have a for loop which iterates over adjacent vertices of previous chosen vertex. We check if smallest patch of vertex I is greater than that of vertex U from Q plus distance between them. If so, we update shortest patch for vertex I. At the end of a for loop, we remove chosen vertex from vector Q. Function Dijkstra returns array G with shortest patches. At the end of main function, we display shortest patches for all vertices. So, for example, for a graph seen on the screen, we have computed shortest patches. Shortest patch from vertex 0 to vertex 8 is 14. And as we see on the graph, this is true. That's all. Thank you for watching.